having me. My name is John Beverley. As you can see here, I'm an assistant professor at the University of Buffalo. I'm the vice president of the National Center for Ontological Research, formed out of UB, but it's emphasizing connecting a lot of researchers across the world who work in ontology engineering or applied ontology, which is the area I specialize in, despite being in a philosophy department. Although maybe that despite is not worth saying, because the purpose of this talk is to explain to folks how philosophers provide a lot of value in the field that I work in, building ontologies and using them. But of course, I'll have to build up to that because I suspect most of you so far heard me say oncology instead of ontology. We'll remedy that as we proceed, though. So let me give you some background to tell you before telling you exactly what I do. So I know you've probably all heard about big data, right? Lots of data out there, lots of it coming in. There's huge amounts of data that exists already. As of 2022, there's 147 zettabytes of data that's already been stored. If you're like me, you thought zettabytes was made up, and so you started doing a little digging. But just to put this in perspective, a 50 megabyte connection, like something you probably have in your house, will allow you to comfortably stream 4K videos. And at a 50 megabytes per second, it would take you over 600,000 years to stream 1 zettabyte of data. For 147, it would take you over 93 million years. That is a lot of data. This data, so it is indeed big data, right? Like huge amounts. It comes in at an increasingly rapid rate as the years proceed. So as at 2020, 0.4 zettabytes were being generated every day. That figure is way outdated. It's significantly higher now, and it's only going to continue to grow. Some of the sources that the data is coming from are trustworthy, academic research, roughly speaking, trustworthy. Some not so trustworthy, like from Twitter or X or whatnot. And it comes in various standards like JSON LD, XML, like different formats, as well as having conflicts that invariably emerge across data that's being stored. Not everybody agrees, unfortunately. There's not some kind of unified understanding of how the world works. And so people say things, even within trusted data sources or in trusted documents. I don't know if you've ever experienced this, where you had, like, I don't know, two philosophers in an academic journal arguing with one another. Conflicts invariably emerge is the point here, and it happens pretty regularly. We have a bunch of information in the world. We're there. We want to go here. We want to connect this information together in the interest of extracting that last V over there value out of it, which we still can't do for the most part. Now, that might be surprising to you. You may think that, well, John, obviously we can extract a lot of value from all the data that we have. We do this all the time. I'm here to tell you that standard strategies for extracting like knowledge or valuable information out of the data that we have stored in the way I've described now is very hacky. It involves a lot of manual labor. It involves individuals sitting around and looking at screens or databases over here, databases over there, and trying to make connections on their own, illustrating human creativity, but for sure a manual endeavor that takes too long and too much effort from humans to really take advantage of, especially given all the significant amount of data we have. We're nowhere near getting to creativity, as you can see. Now, one of the reasons that the sort of big data issue has continued to be challenging is it's less actually to do with the amount of data that's coming in or how quickly it's coming in or what format it's in. It has to do with the fact that it's often stored in what we like to call information silos. Sure, things like management systems or databases that have content that can't be integrated with that of other information repositories using standard computing strategies. Roughly speaking, like if you put data in one database, according in, like, I don't know, in a docx file, and somebody puts it in another database, and I don't know, whatever, some text file. You have to have a way, if you want to communicate or integrate that data that's stored in one file system from another, you have to have a way to integrate that. Now, Microsoft has figured out ways to do this. But if you generalize this to data being acquired in like, I don't know, the space of viriology or pediatric journals or something like that, and compare that with data that's being stored from like molecular biology, where there's not like a single monolithic company that sits on top of these investigations or research endeavors and says you have to coordinate in this way. Turns out what's going to happen is you're going to generate a lot of silos, a lot of researchers talking in this area and storing their information in a certain way that can't be integrated in standard computing with standard computing strategies in another way. And so folks end up talking past each other, and they often end up doing similar work nearby to one another without not realizing it. This is the consequence of siloing. So these things manifest in various ways. In a lot of cases, people just don't realize that certain information repositories exist. And so when they're creating their information or storing database locally in their systems, they just don't know that there's similar data or nearby data elsewhere. I've been in many calls and many meetings with folks in government, for instance, who where we've like gotten together, a lot of groups are like a lot of members of one agency, members of another agency, and we're sitting in a room, and one of them, somebody says at some point, this happens invariably, if only we had data about this. And then somebody else in the room goes, we do. It happens over and over again. There's so much data out there and so many different groups working to coordinate or organize data. It's very often the case that folks just don't realize how much is out there or what's being stored where. Sometimes even like there is awareness, but there's not appropriate permissions to access data. So in government, for instance, some information is classified, and so some agencies or individuals aren't able to access information that even if they know exists. In the open space, I'm not allowed to access certain information about students. I know it's there, I just can't access it. I don't have the appropriate permissions. These are reasonable reasons to have silos, I think. Like you certainly would want to protect some of this sort of information. More regularly, I think it is the case that there's simply just not the right technology in place that allows access across different databases or different information silos. And so while you can know or have access or in a way forward, even like a desire or a means by which you might integrate two different data sets, you just don't know how to do it in a technical sense. We sort of focus in ontology engineering on addressing that issue, which is what I'm going to be talking a lot about in the subsequent. Before again getting there, I want to throw out this last eye because sometimes people just don't care about integrating other repositories, and so they want to create silos. And at least for comical effect, I think that's crazy. But so silos, if we're thinking about this in the context of big data issues, so we see that what happens is they result in data fragmentation and often redundancy, and they undermine a consolidation or integration, as I said, of this sort of information, which makes it seem like there's a lot more information than there is. Like there's a lot of duplicate data out there because we don't know that database is talking about the same thing that this database is talking about. It also creates bottlenecks that delay information dissemination. And so even though there's a rapid increase of the amount of data coming in, it can actually seem like there's a lot more than it is because we don't understand that a lot of the data, again, related to the first volume question, a lot of the data that's coming in is already there. We're just duplicating it again and again, and there are bottlenecks of understanding what that data is. So in addition, the variety question, I talked about how data is housed in different formats. They're often incompatible with formats and other information silos. And so again, that variety issue comes up. There's like, these different formats make it so that we can't integrate. Also a feature or consequence of information silos, as well as being able to leverage inconsistent standards and undermine cross-data validation. That is another consequence of information silos because, again, we just don't have the technical resources for various reasons to connect these standards or implement cross-data validation for these data sets. And so we can't check to see if, like, when you say over there in your data set that there's a troop movement on this beachhead, and that data set over there, or maybe like an aerial camera looking down says the troops are moving in that direction, that they are not in conflict, or they are in fact consonant with one another. That happens again and again and again, multimodal data coming in and not being able to do cross-data validation by any other means than an individual sitting there staring at a computer screen and figuring it out themselves. All of this, of course, hinders the value obtained by integrating diverse data. So just to put a pin on that, 2020 report by NIST estimated that the lack of interoperability across just industrial data sets cost companies between 21 and $43 billion. And McKinsey estimated mid-sized companies spend about 20 to 50 million annually due to these silos. Again, these are the issues that are causing the problems. It's causing a lot of money lost. So ontologies, the area that I work in, I build these things, I work with these things. So there's a known solutions to information silo challenges in the context of big data, not big data, but I guess that too. And what they are just formally well-defined machine interpretable control vocabularies designed to represent entities and logical relationships among them. I'm going to spell this out quite a bit more, but roughly speaking, I look at data sets in different agencies, different companies, different organizations, and regardless of how they've structured their data, I figure out what they actually meant. I figure out what they really meant. I think I asked hard questions to, say, a physicist about what electrons really are, not just how they model them. I asked hard questions to virologists about what the essence or the nature of a virus is. And what I do is I create a global structure, future-proofing global structure that can sit on top of different data sets and connect them all with at least some semantic layer, so that we can use computers to reason over those data sets or extract information, even though from each of these data sets, even though they're coded in different languages. I give you some examples, but before I get there, if you're taking anything away from this, just take these two here, these two bullets on the bottom here. Ontologies, as we build them here, they make explicit, implicit meanings buried in data sets just by using basic principles of logic. And they provide a semantic layer in doing so that connect information silos. And in doing so, or in pursuance of that, they provide something of a lingua franca across silos that reduces fragmentation and redundancy. And they promote automated data integration, and they standardize a way to extract information from those data sets, as well as exhibiting standard syntax and semantics in common formats and standards, or representing, while the representations leverage textual and logical definitions for consistency checking to facilitate information extraction across these disparate data sets to allow for broad integration. So they hit all of these 5 V's, and they have done so for a long time, and it has become well known, certainly in recent years, that ontologies are able to provide the sort of benefits. I'm sure you've all heard about large language models, generative AI more broadly. Knowledge graph, incidentally, you see knowledge network or knowledge graphs here. Knowledge graphs are just ontologies that have been applied to data. But you'll see all across here, like this item at the top from the National Science Foundation is a huge grant that was set up for like 20 teams right now, or have received funding for this. But what they're doing is building like about 18 different knowledge graphs or ontologies for 18 different areas, like water maintenance, the law, like legal codes or jury duty characterizations or something, like all these different data sets, like 18 of them, and they're going to be integrated within a single knowledge network, they're calling. But a significant effort, a significant amount of money put forward from the National Science Foundation to pursue this. Also, you see here on the right, the Department of Homeland Security, their artificial intelligence roadmap is mentioning ontologies directly. And Gartner, which is on the right and the bottom here, Gartner's future-oriented tech that's going to be beneficial for generative AI. They've identified knowledge graphs / ontologies as the center piece for generative AI's wave and improvement in the near term. As well as we've circled around here, going clockwise to the amount of research that's been generated on knowledge representation or knowledge graphs or ontologies from different countries over the previous years. Again, explosion of interest in what we're doing. But that may just say, okay, John, you've made a case, see at least roughly speaking how these things work, or roughly speaking, certainly a lot of people interested in them. Still, you're a philosopher talking about this stuff, and you're talking to philosophers about this stuff, which funnily enough is the first thing I thought when I sat into a talk with Barry Smith here at UB. I was like, yeah, that all makes sense, man. But why is a philosopher talking about this? Why aren't engineers handling this problem? So let me explain. Little more background. So 98, think about it. Take your mind back there. 1998. the Human Genome Project has taken off. We're about to crack the human genome and find out answers and cures and like resources, treatment options for all sorts of diseases. Perhaps we're going to approach longevity or mortality. Like the world is our proverbial oyster. The Gene Ontology was an effort that emerged nearby, adjacent to the Human Genome Project, as a way to help researchers exploring the massive data that emerged from the Human Genome Project in a coordinated fashion, because they recognized early on that if researchers just went out and kind of made up their own terminology, they could never secure or ensure that they were talking about the same things while they're modeling the human genome. And so this, from its inception, was aimed at providing computational model of biological systems from the molecular to organism level across all species in the tree of life, in the interest of ensuring that researchers who are investigating genes, could talk to one another. Now, when developed correctly, ontologies provide, as I'm pointing to, these common vocabularies or common semantics across multiple domains, which is what the Gene Ontology was aimed to do. The success of the Gene Ontology, and it was very successful, it led to a proliferation of ontologies developed by various subject matter experts, some philosophers, computer scientists, and logicians. And I want to highlight here, when I say the success of the Gene Ontology, it's the most successful ontology that's ever been created. At this point, there's been $3 billion invested in it since '98. It is incredibly successful. But in any event, it was successful early on, and that led to a proliferation of interest in the development of ontologies, none of which, unfortunately, early on were developed in coordination with any other, which resulted in a massive incompatibility of terms and relations, confusion, infighting, and name calling. People got on board with building ontologies, but they didn't do it in a coordinated fashion, and that just kind of duplicated the interoperability or the information silo problem at a different level of generality. Instead of being at the level of data, it was now at the level of ontologies. Now, this spurred the development of a consortium of biologists and medical professionals and philosophers who got together and said, listen, we're going to come up then with a set of standards so that we know that we're building ontologies in a coordinated fashion. One of and you see the principles here. This is the Open Biological and Biomedical Ontologies Foundry, OBO. Now, it still exists. They still follow these principles, but at the bottom here, I'm pointing out that one of the principles that they align to is adopting a top-level ontology, a starting point for all ontology development. And that was created by the philosopher Barry Smith, who's a professor here at the University of Buffalo. He's one of my colleagues. And BFO was adopted as that top-level architecture for the OBO Foundry and has since been adopted by many other ontology foundry efforts, such as the Industrial Ontologies Foundry, and also, I should say, basically across all of the DoD, the Department of Defense, and the intelligence community in the U.S. government. So, and this is a picture of this very lightweight, very minimal ontology. And if you have any metaphysical bones in your body, you're probably seeing some common categories like continuant, a thing that exists in time, occurrent, things that exist over time. You have material entities, things that have matter as parts. You have qualities, and we do mean qualities in the sense you're probably thinking of them. We also have like dispositions, things that can manifest, like solubility of salt, but don't always have to manifest whenever they exist, because a piece of salt stays soluble whether it hits water or not, right? Like we allow like a very high level structure that we used as a starting point. OBO did this, we do this, the Industrial Ontologies Foundry effort does this as well. Like again, a common starting point born out of philosophical and metaphysical reflections started by Barry Smith, under which the Gene Ontology falls. Currently, over 700 projects use Basic Formal Ontology. It is the only ISO standard, I should say, for top-level ontology development. Which is one of the reasons why it's used so widely. And just to dig in just a little bit more, so you can see some of the philosophical meat here. Those boxes that you're looking at, entity, continuant, occurrent, these are representing collections of instances of things. So these are classes. These are classes under which instances fall. So for example, the class of tables would fall under the class of objects, and your dinner table would be an instance of the former. So we make this type token distinction. Also, if you're looking at that, you see in the upper right-hand side, you'll see this ISA, and what that means is arrows. A class A is a class B, just means that any instance of class A is also an instance of class B, which is like a subsetting sort of relationship. Now, Using basic formal ontology as top level architecture, we start there and we build more specific ontologies to cover more specific content with principles that help guide us and help us avoid mistakes. But we cover things like livers, foods, tanks, computers, and we have principles by which we do this extension. Now, I should say some of the methodological convictions, again, born quite a bit out of metaphysics, traditional metaphysics. But some of the reasons why basic formal ontology has been so successful and will continue to be so successful is first that we adopt realism. Now, I know I've no doubt just raised your heckles because you're like, realism, what does that mean? It's a vexed issue. It's a vexed term in philosophical circles. And I should say it's also a vexed term when you're outside of philosophical circles. But roughly speaking, what we mean by realism as a methodological conviction here is that the ontology is designed and its extensions are designed to represent the world rather than just concepts about it. Now, there are ontologies out there that follow what we call conceptualism, where you're attempting to model the way we conceive the world to be rather than the way the world is. And we reject that. We want an external arbiter. We want to make sure that we are focused on trying to model the real world rather than just the way we think the world is. And one of the reasons, just a practical reason, is right here. If we attempt to model the words we use and go to the world, it's unlikely we'll end up in the same place. But if we attempt to go from the world to the words we use, it's much more likely we remain coordinated. And I see this again and again. I'll do some kind of active learning at this step, but I won't belabor that here. But the idea would be I would ask the group, I would say, give me, each of you individually, give me your best definition for car. And I suspect, we get quite a few different definitions for car. And those would be your conceptualizations of what car is. And then we could argue, we could sit here and argue about which definition was right. And I think that's just the wrong way to approach this sort of modeling. What we should do is find what's core across the definitions, where maybe what's core, what an actual car is, like the nature of it, the essence of car, right? And then we start from there to extract the way you think or conceptualize the car. So instead, again, we try to focus on the world, and then from there we can extract the words rather than focus on the words and go to the world. And this is important for us to point out because it is very often the case, very, very, very often the case. We're dealing with people who are not philosophers. They are modeling things out there in the world based on whatever strategy they were taught at mother's knee. They will invariably model the way they conceive things rather than aiming at the world, and it is almost in every case different from the way other people model world or the words. So we again try to get ahead of that by emphasizing realism. We also I want to point out here that adequatism is another methodological conviction we have. BFO itself is non-reductive. We take classes and relations that are motivated by the research communities we deal with, and we don't try to paraphrase them away. To illustrate, this is a picture of Barry here. He's an instance of the class agent, which is a subclass of objects, which is a subclass of material entity. And if I were to follow this up, an agent is just an object that can engage in intentional activity. And an object is a material entity that has like boundaries such that if you were to move some internal part of the object, other parts of the object would have to move as well. And a material entity is just it's an entity that has matter as parts. Now, Barry's an instance of agent. He's certainly an intentional one. And he's also, though, a SUNY Distinguished Professor of Philosophy and a Julian Park Chair. Now, I suspect it's not at all contentious that you would want to include Barry in your ontology of the world, right? Like even perhaps the classes, agent, object, material, entity, but it may shock you a little bit to know that we include as first-class entities things like roles. And indeed, professor role, which SUNY Distinguished Professor of Philosophy, Julian Park Chair, this is an instance of a professor role, which itself is a role, which itself is a realizable entity, where a role is a sort of a property of you that may give you powers or may be able to allow you to manifest certain behaviors in certain contexts, but it's such that if you were to lose it or gain it, nothing materially about you has changed. So if you recall earlier, I'd said there was a class called Dispositions, where it's like solubility of salt. If you think about that for a second, dispositions, these are things such that if you were to gain or lose them, something materially about you has changed. If salt is no longer soluble, something about its lattice structure has changed. And those are contrasted with roles, which is a sibling class. Roles, they're missing that kind of material basis requirement. If Barry gets fired for whatever reason tomorrow, nothing material about him would change. But nevertheless, both roles and dispositions allow you to realize different things. In one case, solubility. In the other case, I guess getting grant money or holding a lot of sway at UB. That's much more likely. So we also represent as first-class entities the relationship between the instances, in this case, Barry and his SUNY professor role. We say that Barry is the bearer of this role. And we represent all of that explicitly in our ontologies. And this is worth pointing out because what we're trying to do is create this, again, semantic layer that sits atop ontology or atop databases. And we're making explicit the implicit semantics in those databases. And so that computers can use those resources to extract information or connect or integrate the data in respective databases. Now, to do that, we have to be very, very explicit because, drum roll please, computers are dumb and they do exactly what you tell them and no more or no less. And so if we want computers to reason through or to integrate data that's connected in the way I've just described here, like Barry Smith, bearer of a SUNY professor role, we have to literally specify that because the machines are not going to infer that information. Lastly, here, I'll say fallibilism is another one of our methodological convictions. While we take our lead from scientific research as it stands, we understand that might change. And if you're familiar with David Armstrong, we kind of take both the adequatism and well, not exactly adequatism, but some of adequatism and fallibilism straight from him. So we are taking our lead as to the nature of the world from researchers who are investigating it. This is not to say that we always agree with them. We do not. I'll show you some examples of where we come apart, but we definitely take that as a default starting point. They may be wrong, and we're open to changing as a consequence, whether it be even at the tippy top with BFO as a top-level architecture or downstream when we extend down to more specific domains. So again, BFO, high-level structure, extend from it into more specific content. We do that by providing in this downward population strategy where we start with something in BFO whenever we're trying to model something on the ground like a table or a chair. And we always try to find where it might fall in the subclass hierarchy of BFO, and then we start introducing subclasses and subclasses and subclasses until we find our way to the ground. And in doing this, we find that it provides guardrails for promoting alignment across ontologies. It helps ensure that they have kind of somewhat common semantics. And what we talk about it in terms of having like spokes that share a common semantics insofar as they have a common hub. Still, okay, I pointed out some of the methodological principles. I gestured at some of the metaphysical background they're stemming from in the philosophical literature. And I've pointed, of course, to Barry, who's one of the pioneers in this field, philosophical in nature. Now, you might be asking, fine, well, why are you here today? Why more philosophers? Okay, first and foremost, I got to highlight, we come up with definitions regularly. We're trying to define things. We're trying to define things that are common. We're trying to find the essence of the nature of the domain or domain level content, things on the ground like livers and Rubik's cubes and viruses and whatnot. And coming up with good definitions is very challenging. I mean, it's challenging. I'm sure you've done it before, but it's even more challenging to folks who aren't trained in it. Let me give you an example. This is just a relationship of some of the ontologies or one of the ontologies directly that sits under basic formal ontology called the infectious disease ontology, and then some ontologies that extend down from it, like the brucellosis ontology, the influenza ontology, or the coronavirus infectious disease ontology. Now, I will hide. This is from my own work where I'll show you where I've used my own philosophical background to like make progress in the construction of definitions and direct researchers who are much more knowledgeable about the content I'll be discussing in a more precise direction than where they'd been headed before. So some biologists in our community who are trying to model things like viruses, they would count. They would use a definition like the sort that I've got here before you, an organism. They'd say an organism is an object. Okay, object is from basic formal ontology, as you recall. And it's a living individual system, such as an animal, plant, bacteria, or virus, that's capable of replicating or reproducing, growth and maintenance in the right environment. And and they also add that as part of the definition, an organism may be unicellular or made up, like humans, of many billions of cells divided into specialized tissues and organs, which implies, I don't know if you've noticed, that viruses are cellular entities, which is not true at all. Viruses do not have cells. It's one of the characters or defining characteristics of them. They're not composed of cells like we are. Now, other biologists in our community who had thought a little bit more about this when this issue was raised, thought of replacing organisms with a class that said organism or virus or viroid, just to draw the distinction. But this disjunctive class that they've introduced, or were attempting to introduce as a way around the problems that I just pointed out, lumps in viruses and viroids in with paradigmatic living things like organisms, right? So why am I bringing this up? Well, it leads naturally to fascinating questions like, are viruses or viroids alive? What does life mean? What separates living from non-living things? And I'll say none of these questions, as interesting as they are, needed answering for the purposes of modeling viruses with ontologies. It's just not like, I agree. As a philosopher, I am fascinated by these questions. There's a lot of research on these questions in virology journals and in biology journals more broadly. They talk about this, they argue with one another, and there's not a consensus around it. Now, what I try to do when I'm modeling viruses is be neutral, because I'm not trying to tell the virologists what to do. I'm not trying to be prescriptive about the way they use language. I think they'll figure it out at some point. They'll have some criteria for distinguishing what's alive and what's not, much like they did with Plato, or the physicists did with Plato or Pluto when they excluded it from the list of planets. I suspect somebody will reach a consensus here. So I don't want to prejudge. And it's not really important for most modeling tasks of viruses to answer such a question. But I tell you, if you go to a meeting with virologists or biologists and you start talking about viruses, invariably somebody's going to ask you whether they are alive. And if you are like me, you will just say, I don't need to answer that question. But why is that important here? Well, I think to me, this highlights some of the value of philosophy, some of the value that I bring from philosophy. So philosophical questions, we're inundated with them, and they're often fascinating, so much that they capture the minds not just of us, but of subject matter experts. Researchers are asking whether viruses are alive because it's a very interesting question, and it's hard to break away from. But we're steeped in these fascinating questions. We know them when we see them. We get trapped in them too, but we're much more familiar with them. And because of that familiarity, I think we have a firmer grip than the subject matter experts on when certain fascinating philosophical questions are not relevant to a given task. And I've seen this again and again, both with me and my students. Like, we know where the interesting questions are, and we're familiar with them. And we also know when the fascinating questions need to be dug into and when they can be put aside for later. Now check this out. This is a Linnaean hierarchy. This is a screenshot from an ontology, by the way. Just a hierarchy. You see all like eukaryote all the way down to brucellosis human patient. Wow, it's really gross. I hate this. It's nasty. It was developed by a physician with very good intentions, though. He was really trying his best to create a model, an ontologically precise model to again, extract that implicit information across databases and making it explicit so we can like reason or connect these things, right? Now, this is a portion of the Ido-Bru hierarchy. This is that infectious disease ontology for brucellosis. And the only classes in that ontology that were relevant to the task of, that the researcher was investigating were just those below homininae. That's all they needed. But they built all of this other nonsense on top of it because, well, I mean, they were trying their best, really. I don't want to throw them under the bus too much. Now, you would see this again in virus ontologies. You see this again all over biology. Now, I built at the height of the pandemic, I was building ontologies for viruses. And we're focused on coronaviruses, of course. We're trying to identify or use the machinery that we leverage in our practice to identify treatment options. We were successful in a couple of cases, but to even get there, I needed to have a kind of robust model of viruses. And I did not want to do anything like this. This was messy. And so what I did was I read a lot of virology work. I read a lot of research, and I found and that there is a sevenfold a sevenfold strategy for characterizing viruses that's in most virology textbooks called the Baltimore classification. Now, you'll usually find it in footnotes. You usually find it in passing. But basically, it's a way of structuring all the viruses that we know of into insofar as how they or what steps they need to go through to get to messenger RNA, which is that little highlighted box in the middle of that diagram there. All viruses have to go through that step if they're going to replicate, but different viruses have different genetic structure, and so different viruses have to go through different steps, maybe through RNA to DNA to positive, negative DNA, but ultimately to that messenger RNA. So it turns out that because of this kind of bottlenecking, you can represent all the viruses there are according to this sevenfold scheme. Now, this is a lot cleaner than a Linnaean hierarchy. I'm sure you agree. And when I pointed this out to virologists who were building virus ontologies in our field, they, in every case almost, they said, wow, I really wish I thought of that. Look, I was not a specialist. I'm not a specialist in virology. And philosophers more generally are not specialists in the scientific disciplines we're working in when we're working as applied ontologists. Because of that, we're not theory laden, we're not practice laden, we're not strategy laden with whatever the scientific domain teaches its students. At the same time, we are trained to frame problems in multiple ways and identify subtle conceptual distinctions and then justify our positions to the extent possible. I was ready with arguments if anybody had anything to say about the use of Baltimore classification. Fortunately, they were kind of on board with it initially because it's so much cleaner. But in my experience, though, these characteristics resulted in kind of an openness to solutions to ontology modeling that hadn't been previously considered, such as the Baltimore classification. I'm not joking. Many researchers in our community had been trying to build virus ontologies and had been building virus ontologies before, but not a one of them had suggested a cleaner hierarchy like the one I proposed here. It's born straight out of the textbooks from their own field. Let me throw another one at you, Virion. You guys know what a virion is? It's a virus in its assembled state consisting of genomic material surrounded by coding molecules. You can think of it as like the minimal virus, it's like a one single virus. If you had to, it's the thing you would count if you were counting a virus. In fact, it's the thing that's counted in titration when they're trying to determine how much virus you need to cause symptoms or something. So, but if you ask 5 life science researchers what this term means, you will no doubt get at least 7 incompatible answers. And options for understanding these, just to illustrate, are things like a virion is to a virus as a virus is to a virion. That's all of these, by the way, I found evidence for, and you can read more about in a paper I published in PLOS One, but I found evidence for in virology literature and medical literature. There's a paper that says virions are just viruses. There's also a paper or several papers that think of virions as to viruses as human gametes are to humans, but also researchers saying that virions are to viruses as human students are to humans, so something like a role you take on or the virus takes on, or similarly, virions to a virus as a human child is to a human, like earlier on in the development stage of a virus, it is a virion. Now, in fact, I found in a textbook, as a matter of fact, one researcher at least talking in 2 different ways. I think what happened is they defined virion in one way, and then several paragraphs later, they realized that wasn't going to work for what they were doing. And so they introduced a second definition for it, and they were in conflict, and I guess they never edited it. But what really, like, chew on this. I'm not going to tell you which way I went. You can read the paper, just chew on it. But what I want to point out here is that I was looking at this research. I didn't want to exactly come down and take a firm stand, but I did use knowledge of phase and substance sortals, external, internal properties and stuff to make the case clear to researchers in the community who are building ontologies around viruses that there were kind of subtle issues they needed to address or think through if they're going to start characterizing virions in one or more ways. And also I was using some of this to identify inconsistencies in the way they were talking, which helped clear up some verbal disputes that were going on. It made salient really a range of options for interpreting the varied incompatible ways that researchers use virion, all in the interest of identifying some ontologically sound definitions that helps accommodate how most researchers use the term. Again, I leveraged a lot of philosophy to make these cases. Now, one other. Viruses are often in the literature you see, they're described as being like obligate pathogens. Now, pathogen, of course, is not used consistently in life science research. And unifying that ambiguity seemed to require like a deep understanding of pathogens, as I understood it, as indexed to species or to stages in the development cycle of a species. Now, the literature on pathogens is all over the place. Researchers talk in many different ways. They talk about pathogens as like specific material or types of material things. They talk about pathogens in terms of what they can do. They talk about pathogens as like measurements of things, and they often do this without being very clear about what they mean. And so that generates a lot of confusion and researchers talking past each other. I think there's kind of like a core way to understand viruses insofar as they're pathogenic. And that goes back to what I was describing earlier about their dispositions or the dispositions to do various things, pathogenic things. And so I had proposed this definition, which is quite complicated, but in the best of possible ways. So I think of a pathogen as something that has a pathogenic disposition, which is just a disposition borne by some material entity to localize or produce toxins that can be transmitted to an organism, either of which may form a disorder in that organism or immunocompetent members of the organism species. This is quite complicated, right? But it was necessary, I thought, I still do, necessary to have this kind of breadth to capture the way that folks were in the research communities were talking about dispositions while respecting what seemed to be going on as a matter of fact in the world. Namely, like I have various cases, as you can see here, like C. botulinum is supporting some of this. Researchers talk about botulinum as a pathogen, but botulinum, like for instance, doesn't actually like localize in you to exhibit its pathogenic properties. What happens is it kind of it might be like sitting around or like moving through your system while producing toxins that generate disorder in you. It's not the same as like SARS-CoV-2, which localizes on you and starts infecting your cells with various like nasty replication cycle features, or Staphylococcus aureus, which is an opportunistic pathogen that also localizes in you in the right context. So again, why am I highlighting this? So philosophers, as I said, as you're probably clear from now, are often trained in conceptual analysis, formal logic, and we extract information from dense philosophical texts. We train our students to do this. We do this ourselves. This training not only aids philosophers when identifying subtle distinctions in research areas outside their interest, but also aids them when coming up with using common applications employed for ontology development. Like I thought very deeply about the way that researchers are using pathogen, and I could see a common structure across the way they were using it. Now, it's not exactly pretty, but it is informed by what's going on out in the world, and it was good enough to get a lot of folks on board and say, you know, this is actually, as vexed as our use of pathogen is, it's actually not that bad. It really covers a lot of the cases. Now, I'll just summarize here, and then I want to talk about one other thing. But summaries so far, philosophers tend to have a firmer grip on when certain fascinating questions are relevant or not. And they tend to be open, I find, in my experience, to more possible ontology modeling solutions than other researchers in their specific fields. And we're trained to identify definitions that accommodate disparate use cases, using some of the metaphysical training that we get or logical training that we get, as well as the conceptual analysis training that we get and the ability to persuade others to coming on our side. Now, I said one other topic, and then we can discuss it at your leisure, but I do want to highlight, though, I mentioned that there are a lot of people getting on board with the ontology engineering, a lot of people getting on board with unifying data sets or connecting information. And I will also add, a lot of people are getting on board with philosophers doing this work. So here, this is just from LinkedIn. Ontology all over the place. People are looking for ontologists to hire to do exactly the sort of thing that I've been describing in this talk. Note too, though, that in many of the required skills or basic qualifications, you're going to see philosophy pop up. They know philosophers are good at this. I will share this anecdote with you as well. I used to work at Johns Hopkins in the applied physics lab before becoming a professor here. And I worked on a team with researchers like machine learning specialists, folks doing like standard NLP, but also folks working in chemistry and virology. And we worked as a unified team using ontological solutions to help do things I can't actually talk about. But I will say at various points, researchers, well-meaning researchers, would get into disputes that bordered on philosophical, and they would call the philosophers. And that was a common thing that you would see in the Slack channels Or I would get an email that said, we need to call the philosopher in. And they weren't joking. They weren't saying it facetiously. They would literally say in meetings, call the philosopher. I don't know how to handle this question. It's too much. They got a feel for the depth of the sort of questions they needed to address, and they hired philosophers to handle them. Philosophers who had like an ontology engineering background, of course, but nevertheless, philosophy was front and center of why we were there. Now, so one thing you can take away from that is that if your parents ever give you grief for being a philosopher or something, they say, what are you going to do? Go work in a philosophy factory? Yeah, maybe. Like that's the upshot. Maybe you will. Also, you can point this out. These are like six-figure entry-level jobs. And if you don't believe me, just ask our community. This is an incomplete list, but these are philosophers just from UB that are working in philosophy. Some of them work here. So Regina there is hired recently as an ontologist. We schooled together at Northwestern. She followed me over here, which I'm happy for. But a lot of these are graduate students that came out of UB. Again, as I said, there's an incomplete list. There are quite a few, and they are making quite a bit of money, more than I am. And we are all over working in, whether it's in government organizations, whether in banks, whether in like think tanks, whether like over here at La Jolla Institute, we have like research labs, also at University of Buffalo. Our researchers are everywhere. And there's, I can't tell you enough, like Barry and I get requests for talent every other day, and we do not have enough people to send. That is just the state of the game. Any graduate student here who wants a job has one. Our undergrads have jobs. They probably shouldn't, but they do. Like the field is on fire, and we are a centerpiece of the flame, right? Like people look here for talent to do this sort of work in various sectors. And as I'm saying, like we just don't have enough people to send out. So we're always kind of looking for help, and because of that, because of the need and my fear about the fate of the field, has led me to do what I'm about to describe. But let me say, I have a bit of fear about the field. So ontology engineering, it's taken off. It's on everybody's lips. Knowledge representation, knowledge graph on everybody's lips. This is not the first time this has happened. It's at least the third time in the history of artificial intelligence. In previous eras, when ontology engineering has been popular, what has happened is there wasn't enough talent to fill the labor gap. And researchers or like hiring managers at different universities or different industries or different corporations, they would look around their field and they would say, well, who can do this work? Well, Jake over there in accounting, he's heard about taxonomies before, so put him in charge of this huge project. And then when it failed, because Jake had no idea what he was doing, they would just put Jake back in accounting and they would blame ontologies. It's easier to do that than to say, oh, maybe we made a mistake. And so I am worried. I'm a bit fearful that this will continue happening if we don't supply or like meet market demand for the ontologists. And so I'm very keen on making sure that we have folks who are well trained and trained well enough to do the sort of work that we do. And so I spent a lot of time training, both like as part of UB and outside of it. So here I'm just going to highlight, I'm walking through this not as a sales pitch. I'm not trying to take anybody from any university. I think where you are is good and you should stay there and learn your philosophical chops. But if you are interested in joining or learning more about this, everything I'm about to talk about is open to the public, remote, recorded, and the minutes are online here, and you're welcome to join Slack. So, but here, just ontology and intelligence analysis. We work with a lot of government folks. And so I'm teaching a course about how you can apply ontology engineering to intelligence analysis. There's a picture of the GitHub repo and a link to it as well. Again, all open source, all the lectures are there, all the videos are on YouTube. You're welcome to check them out. Also Logic for Ontologists, where I get into the real technical weeds. I'm a logician by training, so I really love this course a lot. But if you want to see more about that, you can go look at the YouTube channels and also perhaps join the Slack. As well as these standing meetings that we have and we've had for several years that cover various topics at certain levels of sophistication in our community. Ontology 101, of course, is the intro, happens every Wednesday, 11 to 12, also open, public, remote. Meetings are recorded and online, as well as some of the more sophisticated or a little more sophisticated ontological meetings like the Common Core Ontologies. It's one of our bigger extensions of Basic Formal Ontology. A group of people are focused on just applying that in their various circumstances. And then lastly, that semantic mapping meeting that's kind of in line with the logic for ontologist work. It's really technical stuff. Again, I love it. I'm smiling as I'm talking about it. I can't help it because I love formal stuff. But anyway, you can find more information about all of that on this webpage here, Incore Ontology. I'm highlighting here the Incore 101 working group, but you can see over the left we have quite a few others and a misspelling of Graduate Applied Ontology Society for some reason, which I'm going to fix after this. But with that, I will stop and let's chat.
I have a question. I couldn't figure out how to raise my hand. I didn't find it. So one of my good buddies, he's an ontologist. He's been doing it for, I forget, 3 or 4 years. And when I go and visit him, I ask him what he does, and he sits there and he shows me what he does. And a lot of it seems like he's exploring ontologies, like he's doing queries, right?
Yeah.
And I guess my question was, is that what you do most of the time? Just explore ontologies and I guess like get rid of redundancies, or I don't know, even if you get rid of redundancies, but like, do you spend your time sending out queries and trying to find where there might be, I don't know, holes in the ontology, things missing, and then build? Is it like querying seems to be a big part of like being an ontologist?
For some people, for sure.
Okay.
So there are different like areas of emphasis, right? Like some people do more or less what I've described here. We're like talking with subject matter experts and like really trying to think carefully about the structures they have in mind. And like there's so much low-hanging fruit out there that still needs to be modeled. That's going to be an opportunity for a while, right? As we explore more and more of the world. But then there's also the information extraction side, and like people do both. Like I do both, but you can like use various like query languages to like extract information from databases, with or without ontologies. You can like provide queries to help, like structures to help you gain information or extract certain types of inferred information from ontologies. And I mean, I like doing that because it's a way to explore like that implicit information that's being embedded in. Like once you build a structure well enough, you have like such a rich environment to like identify hypotheses or identify like new research areas. And I'm honestly I'm in this game because I want to be immortal, and I have no idea how to like gear research that way. But I assume I'm hoping that if we like integrate all the data and start querying it, then I will find such a path. And I'm trying desperately to do that before I die. So, but like to answer the question, column A and column B, there are also folks who kind of just do the formal logic side of what we do. So there's like there's what we call, it's called description logic. It's weaker than first order logic. It only has binary relations, for instance, and it kind of underwrites all of the representations that we do, which raises challenging puzzles when you're trying to represent, like, I don't know, John having a part or hand part at one time and not having a hand part at another. If you're familiar with David Lewis and like disputes over the ways you might like like model like time, like those same questions come up in these like engineering discussions, which is fascinating to me. But so there's some researchers that focus largely on the formal side, like trying to identify more or less expressive logics that we can use. And the barrier that we meet is like we don't want to make it so expressive that it's undecidable, which is why we don't just use first order logic, because first order logic itself, you can't always be sure if you said something false that you're not looking at a loop. Like, and so there's like a balancing act, and it's kind of underdeveloped, honestly. So I work in that area. If anybody else wants to join me, feel free. But those are just 3 off the top of my head, like different areas you might emphasize when you're doing work.
It's, I guess, kind of a follow-up real quick. Knowing query languages and just being able to run queries, it's an essential skill for an ontologist, no?
I think so.
Okay.
I think so. I teach a lot of it. But honestly, like it used to be it used to be a bigger barrier to entry because mostly
Yeah.
if you're familiar at all with like querying languages, SQL, which is really widely used for like relational database structures, which don't have the same structure that we use. And there's so much support, textbooks and courses for SQL.
Hmm.
Our community has Sparkle, which
Yeah,
is
I've used that. Yeah.
yeah. So Sparkle, and you probably know there's not that much support, not a lot of textbooks on it, not a lot. And so it used to be a significant barrier. But now with generative AI, I actually teach my students, I'm like, I just need to teach you the right prompts so you can get, it'll write the query for you. Just use that. So
Okay.
much less of a barrier. Mhm.
Okay.
Yeah.
Okay. Yeah, that's helpful.
And I would encourage you, like, it's not perfect. You still need to understand it, like
Right.
to debug, but like at least you don't have to type all that stuff out over and over again. Like
Yeah,
it's,
they get pretty long.
yeah, it really saves a lot of the hassle. So,
Okay. Okay. Yeah, that's helpful. Thanks. Yeah.
yes.
Well, yeah, no, I guess I had a follow-up on Josh's question, which was one thing that ran through my mind in your talk was just a question about whether being a data ontologist will survive like the large language model revolution. Like, is this the kind of work that is protected from being replaced? Like, part of your response to the previous question seems to indicate there's a large part of the job, the coding part, that you really don't,
Right.
need a human. You just need a prompt engineer.
Yeah, that's a great question. I think the answer, if anything, generative AI just kind of like highlighted how valuable and hard what we do is. And so the answer to your question is there's going to be space for us. So like generative AI can do awesome things. It's really cool. Like I'm very impressed. But it's also like of this, it's just the most sophisticated attempt at like showing the value or showing the truth of the scalability hypothesis. Like it was basically you throw enough data with the right kind of reinforcement, you're going to get like something like generalized AI or something. You can answer all sorts of questions, it'll give you the right answer, and you can be confident in them. But like this thing was so expensive, so expensive, so intense, so much data, all poured into this best case scenario, and it still sucks. And what is it missing? Well, I mean, it's missing logic, basic logic. It's missing like like actual creativity, like not the sort of creativity that can write, decent enough high school poems, but like you can tell when it writes a good poem or when you see a generative AI poem, when you see Keats, right? Like there's a difference. Now, what is that? I don't know. But if anything, it's highlighting to me that there's a gap between us and that. And highlighting what that gap is, one of the things I do is like I build on top of generative AI. So I can kind of see the gap in ontological representations. I can see what it can't do precisely. And I'm kind of getting closer and closer, I think, to highlighting like the what that creative or whatever it is that makes us so special and why we're not going to be like overridden by no matter how much data you throw at this thing. Like I sometimes like to say it's sort of built in to like the scalability hypothesis, so like natural language processing or machine learning, like they're statistical models. They're not, you throw all the data you want, you're not going to have perfect precision. And if you had perfect precision, if you threw all the data and you trained your algorithms perfectly, what you would get at the end of the day is an ontology. And so what we do is we just add a little of the ontology up front in the training, but that's not going to be able to train itself. So again, all the way wrapped around to your question, is there going to be a future for us doing this? Absolutely. I wish it wasn't the case though, because what we do is actually quite hard. And I would be fine if like we could throw enough data to make it go, like make this job go away, but like I cannot see it. And I'm not at all, it doesn't frighten me at all. If anything, all the advances that are coming out are just kind of highlighting the need. And I think Gartner recognized that. That's why we're at the center, right? Like we weren't at the center of their like hype cycle 3 years ago, That makes sense. I feel like I went on a
Yeah,
pedal.
yeah, no,
there.
no, that
Just
makes
like,
sense. Yeah,
okay.
yeah. I have some other questions, but yeah,
Got it.
I'll
Okay.
let Mark go.
I get excited sometimes. I'm sure you can. Yeah, Mark.
Hi. Yeah, I just have a purely practical question.
Mhm.
So you say like if we want a job out there doing this, there are jobs to be had, no problem. Good.
Yeah.
What if like what if I just have a master's degree? Like, what level of degree do I want to have in order to get this job?
Yeah. So as I was saying, some of our undergrads have jobs, masters have jobs, PhDs have jobs. It really depends on where you want to see your career go. So the advice I typically give is a little ontology training goes a long way. And if you have like those basic requirements, like regardless of whether you have an education, often the need for hiring is so significant that hiring agencies will just kind of ignore degrees pretty regularly if you have the skill set. And so, but depending on what you want to do in your career, it may be beneficial for you to get a master's or a PhD. So if you want to, for instance, go into government and you want to go like up the food chain, which many of our graduates do, PhD and the kind of virtue signaling that comes along with it, it's just very useful. A master's degree, that opens a lot of doors too. Makes it easier to like pay you at a higher salary, for instance, if you're working for contractors. But really, like at the end of the day, though, it's the skill set. We are at a point where having a degree or specific degree is less important than just being able to do the work. Which is why, like, I mean, I'll share this story too. One of our undergrads went to a conference with me about ontologies, and she ran into my old boss at Johns Hopkins in the applied physics lab in the bathroom. And they were only in there for like 3 minutes. And by the time she came out, she had a job offer. She's awesome, by the way. The student's fantastic, but like still, like it's crazy. It's like I say often, I'm like, what a weird world we live in. Like, they're doing like huge layoffs in some areas of like some tech areas, like massive layoffs, like correcting after like COVID hiring and whatnot. And then here we're just philosophers just in high demand. Like, what a weird world, right?
So like on the strategic point still, like it seems like one of the best things someone could do would basically be to acquire training in formal ontology from people who have these industry connections. And then like to get one of these jobs, do you need like a letter writer? Like, are you guys asked to write letters for people, or is it more like word of mouth kind of thing?
Often what happens is folks will, well, so I give the following 3 pieces of advice, and they'll answer your question. So one is come to these meetings. There's like meetings I pointed out, not necessarily like the classes, but like just those weekly meetings. Although if you came to the classes, it'd do the same, because a lot of the students who have enrolled right now, this most recent semester, are from government, and they are here to learn what to look for when they're hiring. So we have like half of our incoming class is from the government and they're hiring people, or they're from companies that are doing hiring in this way as well. And so just coming into classes, you'll get FaceTime exposure. Same with like the standing meetings. You get FaceTime, get people to know who you are. So that's one. That's the first thing I always say. The second thing is LinkedIn. If you're not on LinkedIn, get on LinkedIn and hook up with us so that we're all part of a network. We will promote you as you develop your skills, and people, that's more FaceTime. And the third is if you're not on GitHub, then go to GitHub and get on GitHub. And so GitHub is if you're unfamiliar, think about it as an analogy with like when you're writing in your Word document at home on your local device, and you're like, no, you hit save, and you like write some more and you hit save. GitHub is like a way to do all of that saving at each step in public. So you make a commit, they say, and everything you commit is saved at each point. That way you can never mess up. But it's important because in our circles, and this is not just our circles, but a lot of folks are in engineering circles are like this. Like you send a CV in or somebody recommends you for a position, the next thing they do is they go to see if you're on GitHub because they want to see what you do. Like your CV is just getting you in the door. Me recommending you is just opening the door. But like they still want to see if you can do the work. And I tell my students all the time, I'm like, get on GitHub because they don't know what you're doing otherwise. Like hiding in a room and thinking hard about a problem is not going to show them that you're working. They have no idea who you are. So go on GitHub and just create. And what's good about going on GitHub is you have like a little like history, like every day you're on, you have like a little green dot that highlights like brighter and brighter. So they can just look and see, oh, this person works pretty regularly. They can see the projects you work on. They can see the kind of work you do. If you want to know more about the details of actually what it means to work on GitHub in this space, come to the meetings, because we like, I walk people through how to engage in GitHub and how to make contributions to the community. And it serves both purposes, one, to help the community, and two, to like help their resume. Can you tell I'm afraid of this community? Like I really, I want, come help.
Okay, I have another question then. So you said what they really want to see is that we're doing the work, that we're putting the work in. I guess not having done any work in implied ontology, right? Like for any kind of customer or anything like that. When I opened up GitHub, what is it that I do? Like, are there like resources online, or do y'all provide resources that have like example projects or example ontologies that you can then like, what is it that I would be doing in GitHub to show them that I'm putting in the work? If that helps, if that's makes sense. Yeah.
Let me illustrate. I'll just
Okay.
show you. It's a great question. I'll show you what some of our students are doing.
Okay.
Here, let me share my screen. Can you see my screen? You should see a picture of me making a weird face.
Yeah.
Old photo. Okay, so I'd mentioned the Common Core Ontologies. It's one of the ontology suites that we work on pretty regularly. It's pretty widely used, but you see, so here, this is a GitHub repository. This is where like the ontology artifacts are stored, so people can
Okay.
download them if they want. Like if you went to source, you'll see the ontologies here. Let's see where they are on the more modules. There's like an agent ontology, an artifact ontology, and this is just like, this is the format they're put in. But really,
Right.
like what I want to highlight here is there's issue trackers. Like if you have issues, if you have updates, if you have things you want changed, or just something you've observed that you think could be fixed or corrected or made better in the ontologies, you can open an issue on GitHub. And let's see. So this is one of our students, Alec. He is identified. I haven't read this, so I hope it's reasonable, but he's looked at the definition and he is raising a complaint about it. And this is one of the developers of CCO, the Common Core Ontologies, and he is engaging with him and giving him some guidance. And here's one of our contributors. And so this, if when I'm hiring, this is what I'm looking for. I'm like, is that okay? Good. Good. And you'll see a lot of our students, Greg over here, our former student, actually, Greg's offered a lot of stuff. We have Neil, like folks like this. So these are all familiar faces to me. These are people who have done this. There's also a discussion forum where you can do something similar, that we separate discussion from the issues, and the issues are like actionable, like we can fix things now. Discussions are like more open-ended. Like if you have a question about the nature of viruses or something, it might go on the discussion board. You'll see a lot of the philosophical stuff come out on the discussion board, which is why we kept it aside. Still valuable to have, but you know, like that, that's also contribution, right? Like you're moving the discussion forward, and you'll find like the philosophical background coming out there. Like when I'm on there, I'm premise conclusion, looking like I'm doing disjunctive reasoning, I'm highlighting fallacies. I get a little nerdy, but yeah, like I said, when I'm hiring people, that's what I'm looking for. I want to see like the depth of their engagement. And I'll share too, one of my mentees from Northwestern, he raised one issue on one ontology forum or on GitHub. It was a good one. He was like, hey, you're defining assay in too broad of a way, and here's a proposal for how to fix it. 1 week later, they made him a job offer, and he has been working at La Jolla Institute in the biomedical wing for like 2 years now. Like one issue.
Okay.
And he's not the only one. That's happened before, like with some other students, not my mentees, but like this happens not infrequently. Like the field is kind of, if you have the philosophical / engineering, like if you have the philosophical background and the engineering mentality, which is not that hard to get, especially if you're coming to the meetings, we'll get you there. The field is ready for you.
Okay, yeah, that's helpful. And I have one more small question. Do you have this is just because of like my life right now. We just had our first child, very young.
Congratulations, that's awesome.
Yeah. And so like doing things that are scheduled right now, we don't really have control over that. the kid kind of determines, you know, when we're available and stuff right now. If you had to point to like a text or something like that that someone who wants to get involved in this could work through, right, just to familiarize themselves with like the language, and you know how to, you know, but when I get on GitHub, right, like how I need to know what they're talking about, right? So like, yeah. So do you have any recommendations for like text or anything like that?
So my first send me an email and I will send you, like, I have a boilerplate email for this question, and I'll send you that. In
Okay,
fact,
cool.
anybody who wants it, I'm happy to send this out. But I'll tell you right now, like the main text to read is called Semantic Web for the Working Ontologist. And you can find it online, like the second edition. So it's the most recent edition. It basically gives you a lay of the land, just like at a high level, tells you like the tech that we use, the sort of why we use it, what you can do with it, really gets the jargon down. And when I send you the email, I'll also send, I don't know if you're familiar with Anki, this kind of flashcard software. It's really lightweight. I have an
Okay.
Anki slide, like flashcard deck for that book, as well as several other books, which I'm happy to share with you. Like just again, all these resources you can have. In fact, now that I'm saying this out loud, I should put that Anki stuff online, because everybody, I'm going to put it online after this and like highlight it. Folks can use it as well. But yeah, I'm happy to share.
Okay. Yeah, cool. I'll send you an email. Thanks.
Somewhat related question, John, about like the kind of workflow involved in these projects. So are people typically hired by a contractor or a company for a set project, and then when the project is over, they just have work experience and they have to get another job? Or like, are people hired as like permanent employees of the company, and like they're laid off only if the company starts, you know, going through financial pressure?
So often in my experience, often what happens is if there are internships that work like you've described, where they're kind of fixed time frame, and they may or may not be continued based on how good or what the nature of the work is, or whether there's funding. There's contracting work, which is in some areas, like it works just like you've described, but in our area, contracting work is typically for set projects. But when those projects are over, you're so valuable because of the skill set that you have, that there are just other projects for you to work on. Unless the company itself is just tanking, they will keep you on. I've known several cases of ontologists who have just been kept on staff and paid throughout for other projects, because the company knew that like in 6 months they were going to get another ontology contract. It was just it's so much less expensive to like let you go and then try to hire you again than it is to just keep you on. And so that's what's happening more often than not. But really, like the most regularly, what's going on is that folks are getting hired into full-time positions that are not contracting work, but like actual just, you know, paid positions like you would in like a university or something. But these are often in government. So it's a nice cushy government job. So government agencies, many government agencies are really interested in hiring ontologists in-house, partly because they're tired of getting like vendor locked, where they're really keen on like having folks in-house that can do the work. So there's a lot of folks in government who are like keen on hiring out people for this. And that's like a position, if you pass the first year, then and you're not like super high, like political appointee level, it's really hard to lose your job. Yeah. So yeah, some options. I guess I can also say something about the banking side. So the finance industry is hiring a lot of ontologists as well. I have some close friends who are working there, and those jobs are fairly secure. And even if they weren't, from what I understand, you know, as you're part of the network, it's hard to let you go, right? Like I can always move you over here. You can do this, you can do that. And the skills we have are pretty marketable in other areas, right? Like the core skill set is not just like understanding what an ontology is in the tech. It's like strategic conceptual thinking, which any manager will tell you is something that's very challenging to train, and something that's highly valued as like a leader, a sub manager, like for creative projects. Like they can find a place for you. And if you ever get in a point, if you enter this field, you ever get in a position where you're like, I think I might lose my job, you tell me. And we will make sure it doesn't happen. Or we'll make sure it happens and you go to somewhere better. Yeah.
Yeah, Mark.
So I'm following up on Josh's questions. So the picture I had before Josh started asking questions, sorry, Josh Tignor started asking questions, was that you just okay, I'm done with philosophy. Tomorrow I want to start working in ontology. That doesn't sound like that's what happens. It sounds like there's a year's worth of retooling I have to do.
I wouldn't even say, I wouldn't even, so it depends on where you are in your philosophical background, really. So I wouldn't say give up philosophy. I do philosophy all the time. I love it. In fact, I'd be loath to do what I do if I'm not doing philosophy. But that philosophical skill set, the thing you've developed, that is a big reason why our students are getting hired. So I say sometimes like the tech side is very easy to get. It's not conceptually that challenging. And I say that, I mean that in all seriousness. Like read that semantic web for the working ontologist book. It's not that long because there's not that much. There's not much to learn. But what is hard to learn is the wisdom that comes from deep conceptual thinking about dense material and like thinking a high level concept, like logically. And that is just not something that most people outside of our discipline do. And you'll see that again and again and again as you work with folks. What seems so obvious to you is not. I once had a long conversation with the head of knowledge representation at a huge company that I can't name. And she was telling me that like over 6 months, they had been struggling over the following problem. They were trying to like model, they were trying to model the case of when a consumer goes to their website and they want, I'll say, they want a candy bar, but they don't want a specific candy bar. And she was like, I don't know how to model that. None of us have figured out how to model that. Maybe 6 months is a stretch, maybe like 2 months. They've been struggling over this. So like I said, listen, you just have a class candy, and then you have subclasses for the types of candy, like Snickers, Kit Kat. And then when somebody wants a piece of candy, but not any specific piece of candy, it's outside all of those subclasses, but there's an instance outside of those subclasses, you don't know what it is, but that's it. And she thought and she paused and she was like an uncomfortably long silence. And then she looked at me and she said, oh my God, I think you just solved this problem. But it probably seemed very obvious. We probably knew what I was going to say before I finished the sentence, right? But like, they're just not trained to think that way. Much like we're not trained to think in whatever like specific like engineering strategies or languages that they use. We have our own special skill set.
Right, but that wasn't, so the question you answered was,
Uh-huh.
why choose philosophers? Great. My question is, how much work do I have to do to get into this? Like when I started applying for those jobs at LinkedIn, you can circle that bit that says philosophy, but I didn't look carefully what the rest of the requirements were.
Yeah. Read that book. That's Semantic Web for the Working Ontologist. So I was trying to answer that part of the question too, right? Like, so that book, read that book. The tech is not that hard. Getting the language down, not that hard. Most often what happens is folks will read this book, they'll come talk with me, they'll come to these meetings, they'll go learn the actual details on the job. But what they can't learn on the job is the philosophical background. And that's the stuff that's one of the main reasons they're getting hired. So they can pick up the tech stuff. And this is not uncommon in like engineering, honestly. Like it is not uncommon that you have to come in and learn a new stack. Like that happens again and again. They usually give you like a month to get up to speed wherever you are. This is not unfamiliar territory. But they did hire you even in those cases for some specific way of thinking, like in machine learning thinking or NLP or something. And for us, it's philosophical thinking.
So I don't need to take classes and I don't need to get a certificate. I just need to read that book and then I can go to LinkedIn.
Read that book. Maybe come talk to us. Get your face in the right faces. Get a GitHub account so that they know when they're looking around, they want to like see that you're actually doing stuff, right? And like you do those things. LinkedIn, of course, but it's all about like getting your face in the right faces, that minimal understanding of like the jargon, and then playing around on GitHub so that they see you're serious. You come join us.
Okay.
Mm-hmm. You'd be surprised too. Those three things, every time I've recommended people do those three things, like my students, the ones who do those three things get jobs like almost immediately. And then the ones that just do two of them, they're like, how come I'm not getting a job? I'm like, I told you what to do. I just do those three things. But it's really kind of, it's
Well, I mean, like
a
if
weird
I went to
thing,
GitHub
right?
right now, if I went to GitHub right now, I wouldn't know what to do on GitHub. You know,
So you'll need to
if they
come to the
looked at
meeting,
my
right?
work, you know, they'd be saying, is composition real? You know, is composition
Yeah.
fundamental? Right? That's not what they want to see,
That
right?
sounds like a discussion board post.
Okay.
That sounds like, I mean, honestly, like there are debates over that in our field, like composition, special composition question. It comes up not infrequently. It sometimes comes up directly like that, sometimes doesn't. It comes up in other garbs. You'll see like engineers talk about it in different ways. It's structurally the same sorts of questions. You'll be surprised as you start exploring, if you're interested in exploring, you'll be surprised at how many philosophical, like familiar philosophical puzzles start emerging, like ship a Theseus, like natural versus unnatural properties, like yeah. And you're well equipped to like clear up confusion, and that's valuable.
I have another question.
Right.
So I read this book. I go to GitHub. I try and answer some questions, get involved in some discussions. I come to the meetings. When I think about applying to a job on something on LinkedIn, I immediately start thinking, well, there's going to be some kind of platform or something that I need to know how to use, right? Like GitHub is a kind of like information repository, right? Where we can sit there and ask questions and get answers. Are there any like essential, like, I don't know any other word than platform that, you know, that you use to build ontologies and navigate ontologies that I would need to become familiar with?
So different groups use different tools. But
Nice.
you know, if you were looking, for some to check out. So there's this Protégé editor that's the Stanford group creates. It's open source. It's a way to like visualize linking parts of hierarchies to other parts of hierarchies, which is kind of what we do. There's also this TopBraid composer. That's another common one. There are quite a lot of tools out there. Many of these, by the way, covered or at least discussed in that semantic web book, so they'll make reference to these. And often though, that is sort of, I mean, while it's good to have those skills, it's like good to know how to use these various platforms, just like it would be in any other field. With toolkits, like a lot of the training happens on site, right? Because who knows if you're using TopBraid or if you're using some Microsoft developed tool, or like a lot of groups have different tooling that they want.
So like a customer, they'd be more than willing, if they notice you have this skill set, this valuable skill set, they'd be more than willing to say, okay, I'm willing to try you on this project and let you just kind of learn on the go how to navigate these platforms and stuff.
Oh yeah, I started working at Johns Hopkins in the applied physics lab while I was a graduate student. I'd never used TopBraid before. They used TopBraid. And I was like, okay, I guess I'll use this. The tech though is it's lightweight. It's not hard to figure out. It took me a little bit, but I had to learn I learned things like using Jenkins to make builds in the background, Bitbucket and source tree to like organize, like a lot of jargony stuff, right? I learned all of this working there because that was how their infrastructure was, but I knew none of it before. But, you know, I knew how to think deeply and logically about things. And that's call a philosopher, right?
Okay. That's encouraging to hear.
I like to think of it as they're like, I mean, they're kind of hiring us for a wisdom. And I think of philosophy as, you know, study wisdom. Like we're exploring wisdom, right? And it's not a specialty. It's not something you go like get an electrochemical degree in, right? Like we say we get philosophy degrees. It's huge, right? Like covers so much. Wisdom is big. It's not a subdiscipline. And so that's hard to train, hard to get, hard to master, worth it, worth hiring. I'm emphasizing this because a lot of times I'll talk with philosophers and you know, I know what the market's like, right? It's terrible, right? I had no hopes about even attempting. I wasn't interested at all in going to an academic market, but I, you know, it's such a turnabout, right? Like in ontology circles, I'm headhunted. Like people come at me with huge offers, and I'm like, great. Like, it's such a weird feeling. Like, I'm a philosopher and they're coming at me largely for the philosophy background, which is just, it's weird, right? What a weird world we live in.